This is another example involving multiplication of polynomials. In this example here, we are taking a binomial times a binomial, and we are just going to make sure that we distribute. We use the distributive property twice. We're going to distribute this 4n. We're going to take 4n times n, giving us 4n squared. And we're going to take 4n times positive 5. That's going to give us plus 20n. And we're going to take, now we've distributed the 4n. Now we need to do the distributive property with the -1. We're going to distribute the -1, take -1 times n. That's just going to be minus n. Don't need the 1 in front of the n. 1 times n is still n. And when you do this distributive property stuff, you need to make sure you include the negative here. -1 times positive 5 would be -5. We do not want to stop there. We have a pair of like terms. We have a positive 20n and we have a negative n. Those can be combined. If you think of this in the long form, positive 20n is like 20 n's added together, n plus n plus n, 20 of those n's, and then take away one of those n's. What are you left with? Well, you're left with 19 n's. So those two like terms combined would give you plus 19n. And let's just bring down our other pieces. We have this 4n squared, no other n squareds to combine that with, and we can't put these together. They are not like terms. Same variable here, but different exponents. And minus 5. Now, let's take a look at this in a different way. Let's look at this using the rectangular grid model. So, we have 4n minus 1, and it doesn't matter if you write that along here or along here. You can write it as the length of the width, doesn't matter. So it's 4n minus 1, and this is n plus 5. Nice thing about organizing it like this is that it's going to force you to make sure that you distribute the 4n to both of these terms and distribute the -1 to both of these terms. 4n times n is 4n squared. 4n times 5 is 20n. -1 times n is -n. -1 times 5 is -5. And notice it's the exact same answer. You got the 4n squared plus the 20n minus the n minus the 5. Everything's going to work out the same way, and you're going to get this answer right here after you combine your like terms. Now, you might have heard people use the idea of FOIL. And foiling is just kind of like this neat little acronym to help you memorize how you use the distributive property here. So for example, I take 4n times n. That is the f part of FOIL. And the f part of FOIL stands for first. As in, this is the first term of this binomial. This is the first term of this binomial. So you are going to multiply your first terms of your two binomials, 4n times n. So the f part of FOIL in this example would be the 4n squared. The o part of FOIL, o stands for outer. So we have o for outer. And this 5 in this 4n should kind of look like it's on the outside here. This is the outer stuff. So when you take positive 5 times 4n and get that 20n, that is considered to be the O part of FOIL. Moving on to the -1. I, the I part of FOIL, stands for inner. So we have our outers with the 4n and the positive 5, and we have our inners, the stuff on the inside, the -1 and the n. And with this problem, -1 times n gives us -n. That's our I part of FOIL. You can probably guess if F stands for first with the 4n and the n, L is going to stand for last. This is the last term in this binomial. This is the last term in this binomial. You need to make sure those get multiplied. So -1 times +5 gives you -5. So the L part of FOIL would give you -5 right here. This is just a really neat little way to help you, or to force you to multiply each part here, and to make sure that you get the correct answer.